Welcome back. In previous lecture, we discussed about valve symbols and we understood how the valve symbols will be composed of three symbols like piston, position symbols, port symbols, and flow symbols, and how these three symbols integrated together to create a valve symbol which will give me a clear information on how the valve will position or operates so it can impact the actuator, how many ports within the valve, and how the hydraulic oil will flow between these ports. We also demonstrated a physical example on a control valve movement and action, and also we gave some examples in reading the valve symbols. In this lecture, we'll talk about valve actuator, the mode of valve operation, and then we'll talk about the hydraulic cylinders and actuators, which also shall be considered as one of the most important items in a hydraulic system. So let's start with lecture number 17. For valve actuators, there are various modes of actuating the valve. Pedal actuator, push button actuator, manual actuator, solenoid actuator, etc. And these actuators will be responsible to actuate and make the valve operates. And you can find these symbols attached to the valve symbol in hydraulic sketch as an auxiliary item. If we talk about the cylinder or actuators, we have common two types in any hydraulic circuit: single acting piston cylinder and double acting piston cylinder. Single acting means I have only one port in the cylinder body or actuator body, while double acting piston cylinder I have two ports. In single port, the fluid will come from this port and then push the piston for extension, and the piston will retract manually or by using the gravity or spring. For double acting piston cylinder, the fluid will enter from this port to make the piston move or extend, and then in order to retract the piston back, another fluid will come from this port to push the piston in the other area or to do the retract motion. Single piston acting cylinder, one type is called spring return, where the retract process will be done with the help of spring force. And one of the types also in double acting piston cylinder using dual rod. And this means a piston with one rod in right side and one rod in the left side. When we talk in details about single acting cylinder, a single acting cylinder can exert a force in only the extending direction. So the force here, or the force as a result from this movement, will come only during the extending stroke, as the fluid from the pump will enter a plank end of the cylinder, which is normally left side of the piston. Single acting rod do not retract hydraulically, and it will normally retract with the help of spring or gravity. So the force during extension stroke equal pressure multiplies the piston area, and the velocity of the piston during the extension stroke will be calculated by dividing the constant flow rate by the piston area. If you remember these two rules we discussed in section number 1. So these two rules I used to calculate the force created by the cylinder and the stroke or the movement of the piston to extending position. Here I can see the piston doing an extension with the force of value P by A, pressure of the system multiplied by the piston area, and it moved with a velocity Q over A, and when we do the retract it will come back again either by gravity or by using a compression spring in the rod end. Now let's see an example and to demonstrate our knowledge in reading this circuit. I have here a pump with motor, single rotation and single direction. Here is the filter, and then I have a pressure regulator or a pressure relief going to a control valve, and this valve is three-way valve, two positions, two envelope, three-way because three ports, 1, 2, 3, 1, 2, 3, and then the hydraulic cylinder like in this simple with spring. This sketch shows a two position three-way manually operated valve, spring offset directional control valve. Spring offset because it returns back or go to the spring offset mode by using the spring force, used to control the operation of a single acting cylinder. This is a single acting cylinder simple. How I came to know it is single acting, because only one port is responsible for the extension stroke. In the spring offset mode, full pump flow goes to the tank via pressure relief valve. And if you can see here, now let's assume this valve simple telling me that it is in offset spring offset mode because the pump port is blocked. So the oil will go back to the tank through this pressure relief valve, and the spring in the rod end will be responsible to retract the piston as the oil in the cylinder will be drained back to the tank. Now let's see how the sketch will appear in case of operation. Now I have the valve here moved to the position number 1, where the flow will pump going through the inlet port to the valve and then to the port A, pushing the piston to the extending mode. And when the valve is manually actuated, the pump flow goes through the cylinder blanket A via DC1 position. So the fluid will move here through the position number 1, allowing the hydraulic oil to flow going to the cylinder and push the piston in the extension mode. Deactivation of the DCV or direct control valve allows the cylinder to retract as the DCV shift to spring offset mode. And again, if you go back to the previous one, in the spring offset mode, the remaining oil here in the cylinder will be drained to the tank. The pump will face a blank end. There is no more flow, and the oil will be drained through the pressure relief valve to this tank. Here the valve is working and I got the extension stroke from this cylinder. Thank you, and see you next lecture with the control of double acting cylinder. Thank you.